Good afternoon, students. Today we can start the geometric design of railway track. So in the previous semester in highway engineering you have studied the geometric design of a road. Okay. So when I am going to discuss this geometric design of a railway track, the terms will be familiar to you. And geometric design of a railway track discuss all those parameters which affect the geometry of the track. Okay. So the parameters which are affecting the geometry of a railway track is included under geometric design of a railway track, and these parameters are: first one, gradient in the track, and it include rising gradient and falling gradient, and also grade compensation. Okay. Then the next element is curvature of the track, and it include horizontal and vertical curves, then transition curve, sharpness of the curve in terms of radius or degree of the curve, then cant or super elevation on the curves. Last one, alignment of the track, and it include straight alignment and also curved alignment. Okay. So next is the necessity for geometry design. Why we are doing the geometric design of a railway track? So first necessity or first objective is to ensure the smooth and safe running of trains. That is, if you are not doing the geometry design and simply laying a railway track, the movement of the train will not be smooth. There will be jerking. Okay, so in order to ensure the smooth and safe running of trains, we are doing geometry design, and also by doing this geometry design we can achieve maximum speed even though in curves. Okay. Then next is to carry heavy axle loads without any derailment. We can carry heavy axle loads. And next, to avoid accidents and derailments due to defective permanent way. So by doing this geometry design, we can avoid accidents to a limit, and also derailments are reduced. And this geometry design will ensure that the track requires least maintenance. If we are doing proper geometry design, the maintenance of the track will be minimum. Okay. So also this will give a good aesthetic appearance. So these are the objectives of geometric design. Next, first element we can discuss what is gradient. Okay. So gradient means it is the amount of slope in longitudinal direction of a railway track. Amount of slope in longitudinal direction of a railway track is known as gradient, and these gradients are provided to negotiate the rise or fall in the level of the railway track. So we can negotiate this rise or fall. There will throughout the path there may be rise or fall because our topography is irregular. So in order to negotiate these elements, we are providing gradients in order to have a smooth movement. And the rising gradient rise the track in the direction of movement, and the falling gradient cause the track to go down in the direction of movement. So this rising gradient and falling gradient are very familiar to you, and the gradient is represented by the distance travelled for a rise or fall of 1 unit. That is, rise or fall for 1 unit is the gradient, and it can expressed as 1 in x or 1 in n or as percentage, 1 in 25 or 1 in 500, etc., or it can be represented as a percentage. So gradients are provided on the track in order to provide a uniform rate of rise or fall as far as possible. That we have explained. That is, on a since our topography is varying, there will be rise and fall on the surface. So in order to smoothen these variations and to provide the uniform rise or fall, we are providing the gradient. And another objective, to reach the various stations located at different elevation. By providing this gradient, we can reach the stations which are provided different, which are situated at different elevation, and it also reduce the cost of earthwork. Okay. If we are not providing gradient, or if we are going to give straight path only, we have to do a lot of earthwork by filling and removing the soil. So cost will be very high. So for reducing that cost on this varying topography, we are providing gradient. So here this is the falling gradient, then this is the rising gradient. Next, gradients, classification of gradients. Gradients are classified as ruling gradient, momentum gradient, pusher or helper gradient, and gradients in station yards. Similarly, you have studied the different types of gradients in your highway engineering also. Okay, like that here also gradient is classified into 4 types. So first we can discuss about ruling gradient. So ruling gradient is the steepest gradient that exists in a section. It is the steepest gradient which is existing on that section. And based on this ruling gradient, we can determine the maximum load that can be carried by a locomotive. Because if the gradient or the slope is very high, it is very difficult for a locomotive to carry the load. Okay, that is through a slope, the load carrying capacity of the locomotive will be minimum. So based on this steepest slope, we are determining the maximum load that can be carried by a locomotive. So based on this ruling gradient, we are determining the maximum load. And in plain terrain, this ruling gradient is 1 in 150 to 1 in 250, and in hilly terrain, this ruling gradient is 1 in 100 to 1 in 150. Okay. Next is the momentum gradient. So momentum gradient is steeper than ruling gradient. This is steeper than our previous ruling gradient, and it can be overcome by a train because of the momentum it gathers while running on the section. That is, in valley, a falling gradient is sometimes followed by a rising gradient. That is the situation in the case of valley. There will be a falling gradient, and after that there will be a rising gradient. So in such situation, a train coming down a falling gradient acquires good speed and momentum, and this will give additional kinetic energy to the train and allow it to negotiate gradients steeper than the ruling gradient. That is, as I have told, this momentum gradient is steeper than the ruling gradient. So in the case of valley, there will be a falling gradient which is followed by a rising gradient, and this will be the this gradient will be steeper than our ruling gradient. It is the steepest gradient. Okay, so when a locomotive which is traveling through a falling gradient, it will acquire maximum speed and momentum because it is traveling through a through a falling gradient. Okay, so it will acquire maximum speed and momentum, and this will give this maximum speed and momentum will give kinetic energy for this locomotive to travel through this high rising gradient or steeper gradient, which is steeper than our ruling gradient. That is, using the momentum which is acquired through this travel is used for carrying or used for moving on this gradient. So that is known as momentum gradient, because this maximum good speed and momentum which is acquired during the travel along the falling gradient is used to it will provide additional kinetic energy to the train, and it will allow that locomotive to negotiate the gradients which is steeper than our ruling gradient. Okay, it's clear. That is, in valley there will be falling gradient, and after that there will be rising gradient. So the momentum which is acquired during the travel along this falling gradient is converted into kinetic energy, which is used for negotiating this steeper gradient. Okay, so it is known as momentum gradient. So in sections with momentum gradient, there should not be any obstacle. That is, there should not be obstacle in the form of signals, etc., and it will bring the train to critical juncture. So there should not be any obstacles when this locomotive is traveling through a momentum gradient. So this is about momentum gradient. So this is the practical situation where there is momentum gradient. That is, there is a falling gradient which is followed by this rising gradient, and this is the momentum gradient. So the momentum which is acquired through this travel is used as the kinetic energy for negotiating this curve. Okay, sorry, so for negotiating this gradient. Then third type is pusher or helper gradient. So this type of gradient is provided in hilly regions. That is, in hilly areas, the rate of rise of the terrain becomes very important, because we are trying in hilly area, we are going to reduce the length of the railway line. Okay, in order to reduce the cost. So the gradients steeper than ruling gradient are provided in the case of hilly region. So in hilly region, we have to reduce the cost of construction, overall cost of construction, by reducing the length of the railway line. So we have to give steeper gradient. So that gradient is known as pusher or helper gradient. Pusher or helper gradient is known as pusher or helper gradient because in such situation one locomotive is not adequate to pull the entire load, because since in this case in hilly region the gradient is very steep, we have to provide an extra locomotive to pull the entire load. So it is known as pusher or helper gradient. Okay, here an extra locomotive is required to pull the entire load because here the gradient is very high. Okay, so it is known as pusher or helper gradient. So this provided in hilly region. The last type is gradient in station yard. Okay, so station yard means it is the area which is used to stop our train or locomotive or parking area. So this is the station yard where we are which is used to park our or stop our locomotive, and oiling and all purpose or repairing work is done through this along this station yard. So the gradient in station yard means the gradients in station yard are quite flat because it prevents the standing vehicle from rolling and moving away from the yard due to the combined effect of gravity and strong winds. That is, these station yards are used to stop the vehicle. So if we are not providing it as flat, what will happen? Due to the effect of gravity and strong wind, there will be tendency of the vehicle to move away from the yard. So it is very dangerous. So in that case the station yard should be flat in order to prevent the rolling and movement of the stopped vehicle. Okay, so the gradient should be flat in the case of station yard, and this gradient also reduces the additional resistive forces required to start a locomotive to the extent possible. So in order to reduce the additional resistive force when we are starting the locomotive, it should be flat. So we are providing the flat gradient, and the maximum gradient prescribed in station yard in Indian Railways is 1 in 400, and the recommended gradient is 1 in 1000. So it is a minimum gradient which is provided. Okay. So these are the different types of gradient. Next is the grade compensation. Okay. So what is meant by grade compensation? Grade compensation is usually provided on curves. That is, on a railway track we are providing gradient. It may be rolling gradient, momentum gradient, pusher gradient, etc. So when a curve is there, this grade should be compensated. Okay, the curves provide extra resistance to the movement of train. As a result, gradients are compensated to the following extent. Okay, since the curves provide extra resistance to the movement, so on curves we have to reduce the gradient because on curve the traveling is movement of the locomotive is very difficult. So in India, compensation for curvature is given by, in broad gauge we are giving 0.04 percentage per degree of curve. We are giving grade compensation as 0.04 percentage per degree. Per degree of curve we are providing a compensation of 0.04 percentage, and in case of meter gauge it is 0.03 percentage per degree of curve, and narrow gauge it is 0.02 percentage per degree of curve. So this is known as grade compensation. So based on this grade compensation we can do one problem. So I have told this grade compensation is done only in curves. On flat surface it is not necessary. On curves only we are providing grade compensation. If the ruling gradient is 1 in 250 on a particular section of broad gauge, and at the same time a curve of 4 degrees situated on this ruling gradient, what should be the allowable ruling gradient? Okay, so in this question there is a ruling gradient. Ruling gradient of the track is 1 in 250, and there is a curvature which is coming in front of this track, and the curve is 4 degree. 4 degree curve is situated on this ruling gradient. So at that situation what should be the allowable ruling gradient? Okay, so since it is broad gauge, what is the grade compensation for broad gauge track? It is 0.04 percentage. So as per Indian Railway recommendation, the grade compensation of broad gauge track is 0.04 percentage per degree of curve. Okay. Okay, so for per degree it is 0.04. So here it is 4 degree. So for 4 degree curve it is 4 into 0.04. Okay, so this is this 0.04 percentage is per 1 degree of curve. So since it is 4 degree, we can multiply 0.04 with 4. So here grade compensation is 0.16 percentage. Okay, and the ruling gradient is 1 in 250, and since it is in percentage, we can convert this in percentage also. So 1 in 250 into 100, so the percentage is 0.4 percentage. So 0.4 percentage is the ruling gradient on that track. Since the curve is coming in on front, we have to provide grade compensation. So we have to reduce the grade compensation from the existing ruling gradient. So required ruling gradient or actual gradient which should be provided on the curve is ruling gradient minus grade compensation. So 0.4 minus grade compensation, we have calculated 0.16. So it is 0.24 percentage. So it can be written as 1 in excess, 1 in 470. Okay. So this is about gradients, different types of gradients and grade compensation. Okay. Thank you.